Welcome to the Stormsurf video surf forecast for the week starting Sunday, July 16th. Looking at significant wave heights for the South Pacific Ocean, we see a rather inactive pattern. The storm trap looks like it's basically running over Antarctic ice, and only energy from cutoff lows are east of New Zealand, and by definition, those are not very strong. Let's get into the details. We'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales do form, help direct their track. We're looking for a trough that is a push to the north in the jet stream, and of course, we do not see it. In fact, we're in a split zonal flow, that is the northern branch of the jet running at about 25 south due east. The southern branch down around 65 south, you can see it right here, maybe even down almost to 70, and there's a big hole between the two. That typically supports high pressure in that hole, or if low pressure does form here, it's very weak because the jet stream is not there to help feed it, provide fuel for it. And typically when you see this sort of pattern, again, the southern branch is the main branch for supporting gale development. With no troughs, no dips to the north, there is nothing to support low pressure aloft or at the surface. And of course, low pressure generates winds, winds generate seas. Seas, as they radiate away from the fetch area, become swell, and swell, of course, makes surf when it arrives at your beach. All right, so let's just sort of take a look, and here we go. Something a little bit better starts happening Monday evening under New Zealand. See just a little bit, just a slight push to the north in the jet stream with a little bit of wind there. What is that, 110 knots? Nothing particularly. Oh, there we go. 120 knots by Tuesday morning. Little bit of a trough, not much of one, and the ice line right now is at 65. And we'll see that when we get to the wave models, and we saw it in the previous image. So really, whatever gap is here is mainly over Antarctic ice, so not a whole lot is going to result from this trough. But the good news is a stronger push in the trough, more energy here with 140 knot winds is forecast south of Tasmania on Wednesday night into Thursday morning. Still pretty far to the south, but there is some support for gale development, let's say south of New Zealand by midday Thursday. But then again, we sort of get the trough. Here's another trough actually trying to organize come Friday night, almost Saturday, right on the hairy edge of the Southern California swell window. And most of that, there we go, a broader trough now by Sunday. Off of, well, where is this? So Southern California is about 118 west. So yes, some support for gale development as we get into the outer reaches of the model, mainly for, let's say, California, not Hawaii. But then here's yet another trough, maybe forecast. This is a week out. Don't believe the model's that far in advance. But so, well, they tried another way. The point being, it looks like there is some potential in the atmosphere, specifically the southern branch of the jet, come, let's say, about 4 or 5 days out, and steadily improving from there. So there is some hope. Let's take a look down at the surface and see what is happening. Now again, there's one branch of the jet stream running right along here, the other branch of this jet stream running down here. So this low pressure here, this 996 millibar low, has no jet stream support. There's no jet flowing like this, helping to feed that circulation. And so, as a result, we have, what is that, 25 knot winds? That's it. Certainly, you're not going to get significant seas from that. All right, and looking elsewhere across the South Pacific, also remember the ice line is right along here. So anything south of 65 south, even if you have winds, you aren't going to get any swell from it because it's all over ice. All right, so let's see. Small gale forecast come Monday south of New Zealand, 35 knot winds. Probably not a whole lot from that. You really need 45 knot winds. There's a little patch of 40 knot winds come Tuesday. That's the first, it's a portion of the first trough. And then that sort of fades off, 35 knot winds. You really need more of that. 35 knot winds get you about a 13-second period swell. If the swell is going to survive the 5,000 to 6,000 mile trip up to California and Hawaii, you really need about 45 knot winds. And there we go. Come Wednesday night, a tiny little patch of 45 knot winds, but no, it quickly dies out. Also notice this, big low pressure here over New Zealand, pushing 45 knot fetch up towards Fiji. If you're headed in that direction, this would be of interest to you. And maybe, if the seas were high enough, a small portion of that might eventually reach Hawaii. Anyway, we'll roll this on out. Patches of wind, but nothing. There we go. Whoops, let's go back. Right there. We're on Friday night. Small area, 45, almost 50 knot winds in the California swell window. Is it pushing to the north? Really, it's targeting more Chile and Peru. It's more east-northeast, if anything. And moving, there we go. That's out of the California swell window, little patch 55 knot winds. That's sort of been the pattern so far this year, as all the activity is confined here to the far southeast Pacific, favorable towards Chile, Peru, Mexico. And that's about it. Okay, we're at 168 hours out. Broader fetch. Now, again, this is a week out. Again, not in the California swell window. Certainly in the Mexico, Central America, Peru, and Chile swell window. And there we are. So, not a whole lot looking promising on the surface level pressure charts. Let's go take a look at the wave model. And here we are, significant wave heights. All right, there's the seas. Remember, we still talked about this little cutoff low here east of New Zealand. 25 knot winds, and what's that get you? I don't know, 14, 15, 16-foot seas. Not a whole lot looking particularly promising there. All right, our first little trough gets us an area of 24-foot seas, maybe. Let's see, 20, 22, 24, almost 20, almost 26-foot seas come Tuesday. Maybe some tiny little background swell to result a week to 9 days later or so. But what's that, 26-foot seas? That'll get you 14, 15-second period swell. Yeah, maybe a little bit, targeting somewhat Hawaii and the U.S. West Coast, but then it dies out. Another system forms under Tasmania as we get into Thursday, almost 28-foot seas there. Also notice here's the system in the Tasman Sea, 30-foot seas aimed at Fiji. Mainly 28, 29-foot seas. The system southeast of New Zealand just doesn't really do a whole lot. And then things start getting interested in the southeast Pacific. Now here's the first 30-foot seas. That'll get you 16, 17-second period swell in the California swell window. Not particularly aimed that way, but maybe a hope for some very south-angled background swell. Let's see how this plays out. And there you go. There's your main fetch, 36 or so, 38-foot seas. But again, outside the California swell window, all aimed at Central and South America. That is on Saturday, and we'll just roll this out because there's nothing else going on here. Big, broad fetch, 34, 36-foot seas. We've seen this before on the models, though. 180 hours out, lots of hype, and then 2 days later, it's not even there, and it's gone, so we're not holding our breath on this. All right, let's take a quick look at what's happened the past week. So here we are a week ago. It's 18Z Saturday, so just a hair bit more than a week ago. And we'll just roll through this because if you follow the charts daily, which we highly recommend you do, at least look at the wave model chart if nothing else. Gives you an idea what's going on. So there's this one system here. We'll click away. You can see it right in the middle of the chart there, 31-foot seas. All of it was aimed off to the east. There's no indications that any energy from this was a cutoff low, and it actually developed pretty solidly, pretty much what the models said it would. But it all aimed to the east, all focused on Chile, Peru. So you can see that here. It's actually traveling to the east. There's no indication that any energy is traveling towards the U.S. West Coast. And there we are. We're into Saturday and now Sunday. This is today. So the short of it is nothing has happened in the South Pacific. So the last little bit, I believe it was yesterday, was the last little bit. Maybe some dribbles today and exposed breaks in Southern California, in Orange County. Saw some surf today from the last little bit of that long run, a week-long run of very south-angled swell energy. But after that, there's been no storm activity, and basically there's nothing on the charts. So we're into, as of, there's been no storm activity since, we'll say, Friday a week ago. and there's been none all last week. So we're into pretty much 2 weeks right now. There's nothing expected from the southern hemi. The good news is there is wind swell. High pressure in the Gulf of Alaska, generating the typical pressure gradient. That is low pressure, heat low over Nevada, the eastern part of California. High pressure pushing inland. The difference in pressure creates a pressure gradient. That is, the isobars get closer together. That creates north wind, and then you get wind swell. In the San Francisco Bay Area, there was surf in the head high to slightly overhead range. Rather raw, rather warbly. Nothing great, but there was surf if you needed to go surfing. And of course, you notice down here, Hurricane Fernanda. We'll get into that in a minute. We're just going to kind of ignore, but watch the track here. That's certainly, if you live in Hawaii, that's something to be aware of. Also, this will, or could at least, create some surf on east-facing shores. All right, so we'll roll this out. Wind swell, the gradient continues along North California. Trades will probably start picking up relative to Hawaii. Notice that you get the same gradient sort of thing going on as is going on. There's your heat low right there. This is low pressure. This is high pressure. The closer or the more Fernanda starts moving to the northwest, the tighter the isobars will get, and then you'll start getting trade winds ahead of the actual swell being generated by Fernanda itself. All right, roll this out. Again, 25-knot winds continue into Tuesday. Here, we'll see if we can slide this down a little and get now both Fernanda and the date in there. You barely see it. Okay. And then we're into Tuesday or so. The gradient starts fading off relative to California. Yeah, you get some wind swell, but we're talking more like waist-high wind swell then. Fernanda becomes the focus relative to Hawaii. Notice trades start picking up on Wednesday. There's your high pressure. It actually retrogrades almost back to the date line, but still, you have a pretty good fetch of 15-knot winds. That's wind swell for sure. Fernanda is... the belief is it's peaking out right now on Sunday. By Thursday, it'll be down to tropical storm force. Roll this out some more. The gradient continues weak as the high retrogrades off to the west. Notice low pressure in the Gulf of Alaska. That's going to cut into the high a little bit too. And we'll just see, yes, we have this continued 20, barely 25-knot fetch along the California coast. No eddy flow expected. That means there'll be raw conditions near shore. And then here's the remnants of Fernanda. We're into next Friday, Saturday. Now, originally we saw this system moving northeast of Hawaii, but the latest run of the model has it going remnants right over Hawaii, and the gradient starts building next weekend. Actually, let's go take a look back here. Yes, so Saturday, it's sort of a repeat of what happened this weekend. The gradient fired up on Sunday. It fires up again next Sunday relative to California. Almost looks like there's hope for some eddy flow, south winds along the California coast, and remnants over Hawaii. East wind swell, probably not anything too significant in terms of winds. Some rain for sure relative to Hawaii, and then we get out 180 hours. And high pressure on the return path, moving back to the east. The gradient continues relative to California. Trades solid thanks to the remnants of Fernanda integrating with that high pressure, creating the gradient and, of course, east trades. So here we go, the official forecast for Hurricane Fernanda. Winds currently at 115 knots. That's, I guess we could figure that out real quick here for you. That's 133 mile per hour winds, but out here, so what is that? That's at, can't see it here. Maybe I could drag it off. There you go. At 127, so for about, very roughly, it's only at the equator, but for every 10 degrees, it's normally north-south, it's 600 nautical miles, so 1, 2, 3, about 1,800 nautical miles out, give or take a couple hundred miles from Hilo, east-southeast, and the track is lifting a little bit more northwest, or we'll call it west-northwest. Here we go, at 10 knots. Maximum sustained wind seas right now 41 feet. That's good. That's good for making some swell into east-facing shores, mainly the Big Island. Maybe a little bit of dribbles here into Maui, but probably not so likely for Honolulu quite at this point in time. Forecast is, well, you see right here, it's peaking out with 115 knot winds, and we look back, and that started last night. That would be Saturday night, and it's at its peak, and then a slow decline is forecast. And even here on the 21st, we're down to just about it's tropical storm status, but just barely, and we're still at that. We're 700 nautical miles out, so probably not a whole lot, some very small, we're talking probably 1 to 2 foot, 15, 16 second period swell, but a lot of decay because, again, remember, this is a very small storm, not broad. It's not like a winter storm or one of those storms down the southern hemi. Very small fetch area. Even though the seas are high and the winds are blowing, it's just like dropping a pebble in a pool versus dropping a boulder in a pool. It doesn't get a whole lot of traction, and that swell decays pretty quickly. Anyway, so you sort of get a sense of what's going on here. Latest satellite image from GOES 15 satellite, visible image. You can see what the eye is roughly there. Very concentric organization, as one would expect for a system this strong. Again, small in coverage, but very well organized, and actually kind of surprising to have a system given that we're in an El Nino year, but water temperature, not El Nino, sorry, La Nina year, but water temperatures are still relatively warm in this area. So the outflow would normally be the issue, shearing, but apparently that is not the case. Upper level environment is favorable, and so we have a system to monitor. And then a quick look at the northern hemi, North Pacific significant wave height chart. Of course, here is Fernanda. Seas per the model here, 44.7 feet, biased a little bit high. You need a closer grid model to really get a good, to have the model accurately track what's going on inside a tropical system. 41 feet seems appropriate. Anyway, I'll just roll this out. You can watch Fernanda's track. You see, once you start, it gets up here, still 30-foot seas forecast. That's better in the swell window for more of the Hawaiian Islands, and then, but again, biased on the high sea side. We're down to 20 feet come Friday evening. Still, what is that? About 600 nautical miles from the Big Island, and yeah, good for some swell, but not a whole lot expected. And what's that? Right before it just barely gets into the Big Island, where seas are down to 14 feet. Certainly, that's good enough to generate wind swell. Conditions will probably be pretty raw, though. And we roll that out. Of course, you can see the gradient off of California, and then some spurious seas in the Gulf of Alaska, not doing anything of interest. And one would not expect anything given the time of year. All right, let's take a look at the long term. What's going on with the Madden-Julian Oscillation and El Nino La Nina? That will dictate the swell pattern for the coming months and the fall and the winter. Maybe we can get a sense of what we can expect. All right, first off, we check out winds across the equatorial Pacific, specifically the Kelvin wave generation area that is on the equator from 135 east to 170 west. So this is basically the far west Pacific, 5 degrees north and south of the equator. And as you can see, trades in control everywhere, though a little bit weaker here in the Kelvin wave generation area. Looking at anomalies, differences from normal this time of year. And remember, this is a 5-day average. This isn't actual winds at this moment in time. This per the TAO buoy array, actual buoys down at the ocean surface. We see basically a little bit of westerly anomalies. Not really strong, not indicative of the active phase of the MJO. So the active phase of the MJO tends to suppress trades in this area, and that helps impart energy into the jet stream in winter months. In the North Pacific, and sometimes energy into the jet stream in the southern branch. Now notice, we've been in this split jet stream pattern in the southern hemisphere. Also notice the MJO has been exceedingly weak, if not hardly doing anything at all. So this is how you can kind of see there is a correlation. Typically, when the MJO wakes up, the jet stream wakes up, and in the southern hemisphere, and then you'll get some storm production. But the energy levels in the Pacific are extremely weak right now, and we're not just talking in the ocean, we're talking in the atmosphere above it. Most of that is due to El Nino kind of sapped the energy out of the Pacific, but what it also does is when you move into a La Nina kind of pattern, where all the energy sort of dissipates in the Pacific and the focus becomes the Indian Ocean, and since South Africa is very close to the Indian Ocean, then the South Atlantic, the Southeast Atlantic, and so South Africa starts picking up and getting that's the typical pattern, swell energy and storms, etc. Anyway, so right now a very kind of weak, normal kind of pattern going on. Wind anomalies, zonal wind anomalies, up 850 millibars. This is about 4,000 feet up, but a good proxy for what goes on down at the surface. This is the whole planet on one chart between these tick marks right here. That's the date line. That's the 120 east mark. So the Kelvin wave generation area goes from about there over to about there. You can just scroll down the chart. This is June, going through June and July. Blues are easterly anomalies. Yellows and reds are westerly anomalies. And looking in the Kelvin wave generation area, going right down here, you don't see really anything that suggests westerly anomalies. We've seen nonstop weak easterly anomalies. Here's the forecast. Doesn't look good. Strong easterly anomalies are forecast setting up right now and continuing for the next 3 to 4 days and then mellowing out a little bit towards the end of the 1 week forecast. All the energy, you see it right here. Westerly anomalies, this is where energy in the jet stream would be, is off at 60 east, 90 east. You're talking the Indian Ocean, just like what we talked about before. So this is pretty much, there's these subtle signs that suggest that a La Nina pattern, even though you look at all the official data, it says no La Nina, we're in an ENSO neutral. Clearly, some sort of La Nina biased pattern is going on in the atmosphere. So there's this chart. We have it here on our site. It's a government NOAA chart, but it shows the relative amplitude, the strength of the MJO. We're going back several years, 2011, 2012. You see the MJO, and this is the active phase of the MJO. It doesn't say where it is, but just says relative strength. And you get the sense here in 2013, 2014, the MJO compared to what was happening back here in 2011, 2012, very weak. And then here we are, 2015. So what was it? It was early 2014 that the super El Nino got started, but it really never did because typically you'd see the MJO spiking up. But then you get into 2015, and that's when things really started going nuts. And look at these active phases of the MJO, and this was in the West Pacific. Very strong, very pronounced, solid, and then into somewhere around 2016, and you can see if you drew a line across these tops of these, it would just start heading down and down. We had a pulse in early 2017, and look where we are now. The MJO is just like almost non-existent, and so this is some data that supports, and this is why we're sort of on board with the MJO is weak, not doing a whole lot. All right, forecast for the MJO. This is outgoing long-wave radiation. Sunlight reflectivity off the ocean surface. More sunlight reflectivity, yellows and reds means high pressure, means the inactive phase of the MJO. Less sunlight reflectivity, blues means more cloud cover. Low pressure, the active phase of the MJO. So right now we'll call it weak, very weak, inactive phase, supposedly moving to a very weak active phase, let's say a week out into 2 weeks from now. This per the statistic model. The dynamic model actually showing something very similar. So for the first time, the two models are kind of in sync, but really looking at the big picture, this just forecasts no MJO activity. So we're kind of dead neutral right now, and we're dead neutral, biased, inactive. We'll be dead neutral, biased, weakly active 2 weeks from now per these two models. Phase diagram charts, the ECMF model, we're not going to look at it. This was from July 11th. It hasn't updated for whatever reason. GEFS model, July 16th, the active phase of the MJO, so we're looking down on the North Pole. The heavy dot is where the active phase of the MJO is. And guess what? In the Indian Ocean, where it's been. You can look at past history. It's just been meandering here for a month now or more. So, and the forecast is, so this is they call it, if you're inside this circle, the MJO is extremely weak. So the forecast here, the green dot for the next 2 weeks, has the active phase of the MJO moving over the maritime continent. Let's call that Bali, that area. Maybe almost making it into the West Pacific, but since it's inside the circle, very weak. So that's consistent with what we saw in the other charts. Upper level model forecast for precipitation. We can use this as a proxy for the MJO. 40-day, and this runs about 2 weeks ahead of what happens down at the surface. So this projects that the greens are the propensity for precipitation. We say we'll call it the active phase, the MJO. Inactive phase, currently moving over into the western Atlantic and out of the picture. Active phase, about 2 weeks from now, what are we talking? July 26th, starting to move into the West Pacific and continuing to move over the dateline, but falling apart, and then moving into, we'll call it the East Pacific by August 25th, a weak inactive phase behind that. So all this is pretty consistent with what we're seeing in the other charts. The site that hosts the CFS model that we normally like to look at is down right now, but the last time we saw it, it was saying basically what all the other models are saying. Very, very weak, almost non-existent MJO activity for the next several weeks. Maybe the propensity for some very weak westerly anomalies, but probably not even that, just dead neutral conditions. All right, let's take a look down in the ocean, see what's going on there. West Pacific here, East Pacific here. This from the TAO buoy array. These are the sensors on the anchor strings on the buoy array. You can see actual temperatures, warm water, 30 degrees centigrade in the West Pacific, but not particularly warm, not cooking warm. And the 28-degree isotherm, it was at 145. It's starting to backtrack to 149 now, maybe the leading edge there at 146 or so. But you get the sense that it's pulling back a little bit. Also, the 24-degree isotherm was for a couple of weeks, well, for a good part of the summer, has been all the way into Ecuador. It's backtracking too. This is typically a pattern you see when some sort of La Nina-like pattern, or at least a pulse of the inactive phase of the MJO is setting up. At 140 west, the depth is still right around 100 meters for the 24-degree isotherm. So temperature's holding for the moment. We'll see whether this is just some variation or whether we're actually getting a pullback in warm temperatures. Anomalies. Differences from normal for this time of year, basically 1 degree anomalies spread evenly across the whole upper reaches of the ocean, west to east, the Pacific from 100 meters upward. There was a patch, it wasn't last week, of 2 degree anomalies off of Ecuador. That is gone now. So this homogeneous kind of indistinct pattern going on. If there's some sort of about to get El Nino thing going on, you'd expect to see a big ball of warm anomalies over here, and that's what the active phase of the MJO, when you get west anomalies at the surface, would then start blowing, take that west water, push it into a ball, basically a pocket of warm water that would travel not at the surface, below the surface, and then erupt off of Ecuador. That would be called a Kelvin wave, and that could possibly, when you get multiple of those in succession, then you would start to see the beginning of El Nino. And we quick cut back here to 2015. See these giant spikes in the active phase of the MJO? That's exactly what happened. These active phases produced massive Kelvin waves that eventually washed into, again, over the equator, so into Ecuador, the Galapagos area, and created our super El Nino. Look at one other model, basically depicting the same thing, this kind of homogeneous, half degree, almost 1 degree in pockets in places. Subsurface temperature profile, nothing dramatic, nothing to get excited about. Upper ocean heat anomalies. So here was our La Nina. This is West Pacific here, East Pacific here. We're going back in time. Blues are cooler than normal anomalies. These 2-3 shades of blues We're talking 1 degree below normal or so. So here was our La Nina of 2016. It died around December of last year. Then we got this sort of, you'd almost say it's a Kelvin wave, but it really wasn't. You know, what is that? Half a degree water temperature moving east to west. Some buildup here along the Peruvian and Ecuador coast. Upwelling phase of the Kelvin wave cycle. Another pulse, and here's where we are right now. Just sort of this homogeneous 0 to ½ degree above normal temperature pattern. Notice there was at least warm water in the West Pacific then. If these were Kelvin waves, they fully discharged whatever warm water was left. So that sort of sets you up into this dead neutral zone. And when water temperatures are dead neutral, the air tends to follow. And so it's easy to see why there's just no energy in the MJO. There's no energy in the jet stream in the Pacific. There's not a lot of storm production. It all follows. Water temperatures, water temperatures, Kelvin wave activity, MJO activity drives the jet stream drives low pressure development drives storm development drives swell production. We don't see anything going on that suggests that there's any big push coming. So, and looking at the wave model charts, it's obvious that we're just sort of in this dead pattern right now. Let's take a look at ocean surface temperatures. Now, there is a little bit of good news here. Last week, we saw there's been this persistent area of weak warm temperatures off of Peru and Ecuador. Last week, it was in radical collapse. And you can still sort of see, if you draw sort of a line from here off to here, yeah, there's warm temperatures, but not nearly as pronounced as once you get from about 125 and points westward. But the good news is this was a lot cooler a week ago. Now, at least it's in the positive range. It's not cool. There's this one pocket going on down here. It's sort of retracted. Upwelling along the Peruvian coast is backed off. We actually have some warm temperatures developing there. There's these couple of random pockets of cooler temperatures, but they're being muted out. There was cooler temperatures all here south of Mexico and Central America. They've backed off and is now back in the warm, barely warm. What are we talking about? Maybe ½ a degree above normal sort of thing. So not horrible, but nothing great going on. And specifically, this is water temperatures right there, the Nina 1.2 area, which is off of Peru and Ecuador and the Galapagos and that area. You can see there was this big drop off of temperatures in early July, and now we've rebounded. We're about normal. We're, what is that, 7/200 thousandths, of a degree below normal. You can see we were much warmer back in June, July, and then even much warmer than that in May and April. So if you drew a line through this trying to find the average, you'd say the average temperature is steadily declining in the far east equatorial Pacific. And then the Nino 3.4 area, the main area for monitoring El Nino. Again, this is on the equator, 5 degrees north and south of the equator, but it's off to the west. It's like from 120 west, which is basically south of California, out to 170 west, which is just about at the date line. And this is east of what we call the Kelvin wave generation area. And you can see the temperature variation has been pretty stable. Right now, we're at ½ a degree, almost 0.6 of a degree above normal, right there. And if you draw a line through this, it hasn't changed at all in months. Now, El Nino is considered ½ a degree above normal for 3 consecutive 3-month periods or 9 months. We're not there yet. And ½ a degree is not an El Nino, honestly. We'll just call it neutral biased warm. There's no other signs whatsoever of El Nino in the ocean, in the atmosphere anyway. So we're not even going to don't dare try to stretch the truth. It's just neutral biased warm. Anyway, the trend for the past 7 days, you see neither warming nor cooling here along Peru. Ecuador, a little bit of warming off Ecuador. You get this sort of alternating pockets of cooler and warming. This trend, just a 1-week trend, doesn't mean a whole lot. Still generally warming over here. The Nino 3.4 region starts right here, and you plop it right down along there. So what you see is cooler in half the Nino 3.4 region, warmer in the other half, at least the trend the past week. Doesn't mean a whole lot. This persistent warming thing from California the whole way into the Philippines has held for months now. We think that is a signal of the warm phase of the PDO. And then the backed off view, you can see generally warmer temperatures south of Mexico, Peru, Ecuador, that area, but also this sort of a stream. You can almost pick it out, a stream coming up here along like this. And remember, there is high pressure circulates counterclockwise in the southern hemisphere. So the high pressure surges during the inactive phase of the MJO. That creates upwelling that moves right along the coast here and then tracks off to the east. And then it just kind of dissipates because there's not a whole lot going out here. Then here's our generally warmer pattern here, and you can see cooler off to the north. That's why we say the warm phase of the PDO, but just barely, kind of weak right now. And finally, let's see what's going on in the atmosphere. Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Negative numbers suggest the active phase of the MJO. Positive numbers, the inactive phase. We'll just sort of look down here. We had a kind of a good run of negative numbers there in June. And then July, the balance has been positive numbers, suggesting the inactive phase of the MJO. You look at the 30-day running average, and it runs a little bit late, but we had negative numbers here in June, and you can see that the 30-day average went more negative, down to minus 9.76. That's about as far as it went. And now the trend is heading up. We're almost at zero, again suggesting the inactive phase of the MJO is in control. Looking at the 90-day running average, this is what you can look at to get a sense of El Nino, La Nina kind of thing. If it was down at minus 15, you say El Nino. If it's plus 15, you say La Nina. Looking here, it's just hovering. It got down to, minus 5 or so. And then it kind of held there, and now it's at minus 3, not meaning a whole lot of anything. Basically neutral, maybe biased, slightly active, if anything, but looking at other data, we'd say that's not the case. If anything, it's just dead. Here's the 30-day Southern Oscillation Index average plotted on a chart back 2015. Here was our El Nino, well negative, down minus 20, minus 23 at times. Okay, then we went into La Nina last year, 2016. SOI rises, and now here we are, January 2017, and you see it falling, but not really going very low, and just hovering, if you drew an average right there, somewhere, minus 3 or minus 4, which is nothing. Basically neutral, biased, slightly active. And finally, the CFS version 2 model forecast for the Nino 3.4 region for this week. Where are we? We're somewhere here mid-July. Temperatures supposedly falling, but we haven't seen that yet as of right now. The model is predating something or suggesting that right now we know we're at about a half a degree above normal, and the model says we should be heading towards zero as we get into, September or so, into October. And then when we get into the fall, that we head down to minus half a degree. So whatever warm bias we were in the spring and the summer, we're heading into an equal negative cool bias in the fall and winter, only to rebound next year. So, but this model has kind of jumped around. It was saying we wouldn't get any lower than neutral or maybe 1/10 of a degree, and just in the past week, it's really kind of dipped down here to minus half a degree. So either way, our general sense is that this is probably closer to the truth because we're looking at all the other data. Oh, yes, and there's one other piece of data we need to look at. The ESPI index, like the Southern Oscillation Index, it measures differences not in pressure, but in precipitation in the area north of Tahiti versus here, which is very close to the Nino 3.4 region. That's this area right in here. You see the index is minus 1.97. That means that there is less rainfall than normal right in here, which means that even if the water is warmer for whatever reason, you're not getting rainfall above it. And we know for a fact that at least half of this area, here you go, like that, the part over in here is cooler than normal, and then half of it's warmer than normal. but the net effect is it's not creating precipitation. That tends to predate what's going to happen by 3 to 4 months, what's going to go on in the in water temperatures here, and this has been falling steadily, and it's just been in the past month. It was like around neutral or so, and all of a sudden the bottom just dropped out of it, and this is as deep as it was during last year's La Nina. We think another pulse of La Nina is coming. So when you look at this and see this dip here, this cool dip for the coming fall, the SPI index, that we believe that the SPI index is accurately predicting, and this model is accurately predicting what's going to happen. Other models say neutral, some say warm. We're not buying any of it. We're saying more than likely biased cool for the fall and winter. What that means probably is a dry pattern for California this fall and winter, and whatever storm activity there's going to be, it will probably be from the dateline westward. Not a whole lot of activity in the Gulf of Alaska. But what do we know? We didn't think there'd be a whole lot of tropical activity, and now we have Fernanda. Still, nothing huge, nothing likely earth-shattering, but still, we get something. And so that what that speaks to is you can talk about the inactive, the active phase, the MJO. You can talk about, longer-term patterns, but still, you get storms, you get activity, but the potential for those to develop, or the likelihood that there'll be a long ongoing pattern of storms, is much lower during La Nina and the inactive phase, the MJO. And we believe that is the pattern that is setting up for this fall and this winter. So to wrap it up real quick, not a whole lot of storm activity forecast. Maybe some background swell might get generated this coming week, but that's about it. Wind swell, the most likely source of surf for California. Hawaii maybe get some swell, easterly swell from Fernanda, but that's about it. The long-term outlook, not looking particularly good. Make the most of what you can get when you can get it and be happy with it, because this is the price you pay when you get strong El Niños. Then you get a couple of years after that, the atmosphere has to balance itself out, yin and yang. So you get a good run of surf, now you pay for a couple of years, though it's not horrible. It's not anything like after the super El Nino of 97, 98, where we went into a deep, deep hole of La Nina for years, like a super La Nina. We're nowhere near that. We're just hanging around neutral, and if that's the price we have to pay, so be it. That's not the end of the world. All right, so that's it for this week. We will not do a forecast next week. Next week, we're taking a little bit of a break, but the week after that, we'll do it. So enjoy. We'll do it again 2 weeks from now. See you then. Thanks for watching.